have hard-coded into the system that it can't pass the Turing test.
For decades, when people imagined the far future, they've virtually always included robots in prominent roles. Robots have been portrayed as trustworthy, helpful, and even charming. Despite this, the technology has remained elusive for decades, trapped in the domain of science fiction. Today, we're unveiling a breakthrough robotics advancement from Google that moves us one step closer to a future of helpful robots. The Robotics Transformer 2, or RT-2. So, what is RT-2 from Google? RT-2 is a transformer-based model that can directly produce robotic motions after being trained on text and images from the web. RT-2 transfers information from web data to inform robot behavior in the same way that language models are trained on text from the web to understand general ideas and concepts. In other words, RT-2 can communicate with other robots. What are the learning challenges of real-world robots? Historically, this has necessitated training robots on billions of data points firsthand, across every single object, setting, task, and circumstance in the physical world. A proposition so time-consuming and costly that it has become impractical for innovators. Until now, however, robots were powered by complex layers of systems, with high-level reasoning and low-level manipulation systems operating the robot in an imprecise game of telephone. Consider thinking about what you want to accomplish and then needing to communicate those movements to the rest of your body in order for it to move. RT-2 eliminates that complexity, allowing a single model to not only do complicated reasoning, as shown in foundation models, but also to output robot behaviors. Most crucially, it demonstrates that the system can transfer concepts encoded in its language and vision training data to command robot actions. Even for activities it has never been trained to accomplish, using a tiny quantity of robot training data. Is there a brighter future ahead for robotics? The ability of RT-2 to transmit information to actions suggests that robots will be able to adapt to new circumstances and environments more quickly. Not only does RT-2 demonstrate how AI developments are fast cascading into robotics, but it also holds huge promise for larger general-purpose robots. While there is still much work to be done to enable helpful robots in human-centered situations, RT-2 demonstrates that an exciting future for robotics is just around the corner. Robotic Transformer 2 is a revolutionary vision language action model that learns from both web and robotics data and integrates this information into generalized robotic control instructions. To acquire a comparable level of skill, robots would need to collect robot data from every object, environment, task, and circumstance. RT-2 outperforms the robotic data it was exposed to in terms of generalization, semantic, and visual understanding. This includes processing new commands and responding to user commands through basic reasoning, such as thinking about item categories or high-level descriptions. This also shows that adding chain of thought reasoning enables RT-2 to execute multi-stage semantic reasoning, such as selecting which object, a rock, could be used as an improvised hammer, or which type of drink is suitable for a fatigued individual, like an energy drink. How are VLMs adapted for robotic control? RT-2 is based on VLMs, which take one or more photos as input and generate a sequence of tokens that traditionally represent natural language text. These VLMs have been trained effectively on web-scale data to perform tasks such as visual question answering, image captioning, and object detection. In our study, we modify the Pathways Language and Image Model PALI-X and the Pathways Language Model Embodied PALM-E to serve as the RT-2's backbones. A robot must be trained to do tasks before it can be controlled. We address this issue by expressing actions in the model's output as tokens, analogous to language tokens, and describing actions as strings that can be processed by ordinary natural language tokenizers. The string begins with a flag that specifies whether the current episode should be continued or terminated without executing the remaining orders, and then contains directives to adjust the position and rotation of the end effector, as well as the desired extension of the robot gripper. They also employed the same discretized form of robot actions as in RT-1 and show that changing it to a string representation allows us to train VLM models on robotic data, because the input and output spaces of such models are not altered. The generalization and emergent skills from RT-2. They conducted a number of qualitative and quantitative studies on RT-2 models throughout nearly 6,000 robotic trials. In order to investigate RT-2's emergent capabilities, they first looked for tasks that would necessitate merging information from web-scale data with the robot's experience. And then they created 3 skill categories: symbol interpretation, reasoning, and human recognition. Each assignment needed a comprehension of visual semantic notions, as well as the capacity to operate on these concepts using robotic control. Commands like pick up the bag about to fall off the table or move banana to the sum of 2 + 1 required knowledge translated from web-based data to operate. They observed improved generalization performance, more than 3 times improvement, across all categories when compared to earlier baselines, such as previous RT-1 models and models like Visual Cortex, VC1, which were pre-trained on huge visual datasets. They also carried out a series of quantitative evaluations starting with the original RT-1 tasks, for which we have examples in the robot data, and progressing to varying degrees of previously unseen objects, backgrounds, and environments by the robot, which required the robot to learn generalization from VLM pre-training. RT-2 kept the original tasks shown in robot data and enhanced performance on previously witnessed scenarios by the robot, from 32% to 62%, demonstrating the significant value of large-scale pre-training. With this method, RT-2 can carry out more complex commands that necessitate reasoning about intermediate stages required to carry out a user instruction. RT-2 can also plan from image and text commands, providing visually grounded planning, whereas current plan and act approaches, such as SayCan, cannot perceive the real environment and rely solely on words. Let us look into the advancing robotic control with the help of RT-2. By combining VLM pre-training with robotic data, RT-2 demonstrates how vision-language models can be turned into powerful vision-language action models that can directly operate a robot. RT-2 produces considerably improved robotic policies and, more crucially, dramatically increased generalization performance and emergent capabilities inherited from web-scale vision-language pre-training, using 2 instances of VLAs based on Palm-E and Pali-X. RT-2 is not only a simple and successful improvement over existing VLM models, but it also shows the promise of developing a general-purpose physical robot capable of reasoning, problem-solving, and information interpretation in order to execute a wide range of real-world activities. What do you think about RT-2? Please share your learnings from this video in the comment section below. Don't forget to subscribe to our channel and turn on the post notification to stay updated. Until next time, stay smart. See you then.